In this video, I'm going to talk about how fileless malware can be implemented using PowerShell and how it can be detected. So this is my PowerShell script fileless.ps1, and here is the source code of my script. So the PowerShell script uses invoke expression, and invoke expression can be used to execute a command which is placed in a variable as a string. So this is the command which is executed. Now, if you look into this command, the command is used to download another PowerShell script which is hosted on my GitHub repository. So this is the PowerShell script which is hosted on my GitHub repository. If I check the script, so here is my script. So the script does nothing much other than popping up the calculator process. And apart from that, it prints fileless attack demo to the screen. And after that, it waits till I press enter. Once I press enter, it is going to exit. So once I execute the script, so this is my fileless.ps1 executed. And once it is executed, you can see the code of calc.ps1, which is hosted here, is being executed. So what you see here, fileless attack.demo and enter 1 to exit, is as a result of execution of this script, which is hosted on GitHub as calc.ps1. Now let us see what happens when the script is executed. So this is my fileless script.ps1. So once this is executed, here is the invoke expression code command which is executed, and which in turns executes this command. So what happens when this command is executed? So our calc.ps1 is executed in the GitHub repository. So when this command is executed, calc.ps1 is transferred to the memory, and what you are seeing is the virtual memory of PowerShell. So you can see both the code of fileless.ps1 and calc.ps1. So the calc.ps1 script is not written onto the disk. So it can be known as fileless because this is the payload which is never put onto the disk. Hence, this attack is a fileless attack. But one thing, this calc.ps1 code resides in the memory of PowerShell. If you want to look into the memory of PowerShell, you can use Process Hacker tool, in which you can see the virtual memory of PowerShell's process. So inside PowerShell process, at this particular location, you can see the code for calc.ps1. So this is the code for calc.ps1 in the memory of PowerShell.exe. Now the question is, can this be detected or not? There is always a hype that fileless attacks can never be detected, but it can be detected. So it can be detected with a technology known as memory scanning, which is there in a lot of antiviruses and EDRs, but might be disabled because it causes a performance issue. So this can also be present in Yara role, in Yara as well. So let me show you how we can do memory scanning using Yara. You can scan the memory of a process in Yara using the same command. This is the Yara binary -R. This is the rule name, and this is followed by a PID. So this is the PID whose memory you want to scan. And let me show you the rule quickly. So this is the fileless.yar rule. It only has the pattern fileless attack demo, which is a part of calc.ps1. And now let me run the Yara scanner. So this one scans the memory of PowerShell. And here you can see the Yara is able to detect PowerShell with the Yara rule. So now it is detected. If you want to know more about malware reverse engineering and detection engineering, you can visit academy.intellit.com and you can fill in this form if you are interested in the training. Thank you.